Organizations are now deploying AI agents to manage financial portfolios, generate compliance reports, and execute binding legal contracts. When an AI moves capital or drafts a legal agreement, your enterprise assumes the liability. If a client contests a transaction or a regulator audits a document, you have to prove exactly what your AI outputted and prove that no human employee altered it after the fact. If you are looking into the Agent Witness Protocol, or AWP, you are likely searching for a way to mathematically guarantee that your AI-generated documents are legitimate and factually accurate. We need to clear up an industry-wide misconception right now. Cryptography cannot prove that a digital document is inherently true, or that the data inside it was legitimate at its origin. No protocol can do that. The actual goal of enterprise AI security is securing undeniable, mathematically provable evidence that a specific digital event occurred exactly as recorded. AWP is a receipt generation system. This flowchart outlines the difference between how most companies handle these receipts today and how AWP secures them. The standard approach relies on self-hosted logs. The AI takes an action, and the system records it in an internal database controlled by a single admin. If an auditor asks to see the log, they have to trust that your admin didn't tamper with the data to hide an error. The AWP path removes that internal database from the trust loop. When the AI generates a document, the protocol creates a locked cryptographic receipt that can be verified by an independent third party. That receipt proves the exact millisecond the AI touched the file, the specific human credential that authorized the agent to act, and it provides mathematical certainty that not a single byte has been altered since that moment. By focusing entirely on tamper-evident integrity, your organization builds a technical defense that does not rely on taking your IT department's word for it. To handle documents securely without violating data privacy laws, AWP uses a configuration called the doc profile, which relies on a mechanism called a cryptographic hash. When an AI interacts with a file, AWP never stores the sensitive content. Instead, it generates a fixed-length alphanumeric hash. That unique digital fingerprint is locked onto the timeline, proving the document existed without leaking enterprise secrets into the log. This privacy model creates a specific trade-off. If an auditor wants to verify your AWP receipt later, they must possess the exact, unaltered original file to see if the hashes match. If your team loses the source file or quietly deletes it to save storage space, the cryptographic receipt is useless. The math only works if your data retention policies match the rigor of your logging protocols. The core architecture of this system relies on a neutral witness topology. If you host your own AI audit logs, you are effectively grading your own homework. AWP solves this by routing your logs through an operated, neutral third-party witness, packaging the data inside standard cryptographic envelopes, specifically DSSC and in toto formats. Because the witness is a neutral third party, the verification is zero trust and operates offline. Anyone, from a regulator to a client, can download the open-source AWP tool and verify your agent's actions on their own machine without asking your company for an API key. The trade-off for this level of transparency is that you surrender the ability to quietly delete or patch AI mistakes. The receipts are chained together using a Merkle tree structure, meaning if you try to alter a single historical log, every subsequent node in the chain will fail verification, making the tampering glaringly evident. Giving up unilateral control over your own error logs is uncomfortable, but it is the mandatory price an enterprise must pay to secure credibility with external regulators. About 80% of AWP is built on existing commodity cryptography. The remaining 20% is the protocol's primary differentiator, the typed honesty boundary, which operates using specific tags called clean classes. Rather than relying on a company's marketing promises, AWP hard-codes a strict taxonomy of clean classes directly into its architectural schema. The system can only assign tags like integrity since witness or verified against. The protocol lacks the code to assert a document is authentic at its origin or represents absolute truth. It forces honesty by design. If a developer tries to force the system to claim a file is legally authentic, verification simply fails. By making it mathematically and grammatically impossible for the system to overclaim what it actually knows, AWP protects your organization from liability based on misunderstood logging claims. Once you secure what the AI did, you have to prove exactly when it happened. AWP handles this through external time anchoring. Instead of relying on your internal server clocks, AWP anchors the routes of its cryptographic checkpoints to external time sources that your enterprise has no control over. This provides an honest third-party time-bound. Using systems like open timestamps or eIDAS qualified providers, the protocol proves the AI action existed no later than a specific millisecond on a specific day. The choice of time anchor involves a trade-off between speed and cost. Free, trust-minimized options like open timestamps require waiting hours for block time confirmation. If you need immediate, legally qualified verification, you have to pay for an enterprise-grade regulatory vendor. Achieving time certainty requires trading either patience or budget. In exchange, you eliminate the ability for anyone in your organization to fraudulently backdate a log. So, is AWP actually necessary for your specific AI deployment, or is this just engineering overkill? To decide, you need to map your AI tools across two axes: your regulatory risk on the vertical axis against your need for independent auditability on the horizontal. If your AI is summarizing meeting notes or drafting emails, you operate in the bottom left quadrant, where standard internal logging is sufficient. But if your AI generates compliance reports or executes financial transactions, you are in the top right. For low-stakes tasks, implementing third-party cryptographic receipts is a waste of resources. But for high-stakes, client-facing actions, AWP provides an essential engineering blueprint. AWP takes commodity cryptography and wraps it around a highly specific, legally honest taxonomy for AI actions. The timing is critical. Legal frameworks like Article 12 of the EU AI Act are transforming tamper-evident logging into a strict regulatory mandate for high-risk systems. For engineering and compliance leaders, the priority is to discard the hype. Cryptography cannot prove that your AI is telling the truth. The true defensible value of this protocol is much more practical. It provides a mechanism to undeniably and transparently prove exactly what the AI did. Maintaining verifiable offline evidence of an action, governed by strict honesty boundaries, provides a rigorous defense for organizations facing auditors, courts, and regulators.